Alright, now in part 2 we're going to create our own homework assignment, and we now have these two repos in here. And we'll navigate to the homework generation one, and we're going to use this file stub assignment to create our assignment. It's a Python script. I'll run it up here. We need to give it a name for our first assignment, let's say homework 1, and we need to tell it how many problems there are going to be on the homework. There we go, and now we just created this folder in here. It contains a single Sage file, generate assignment, and it's kind of a skeleton for creating problems. We need to input a function name, what are the input variables, help text, default answer, number of test cases, and the likelihood of revealing a test case to students, a maximum time that the student code can take to deliver an answer, a handler that creates correct answers to compare against. I need to do this for each problem. Just so that this doesn't take forever, I'm going to go into the demo assignment folder that comes with the repo and copy the generate assignment info from there. I'll just copy it down from the info and go into ours. This is homework 1 and paste this in here. Go back up to the top. Close this one. Okay, so in the first problem we're going to create the lowest common multiple function that's supposed to input an integer, help text, just explain in few words what the students are supposed to do, the default answer. It's usually safer to give it as a string. In the case of integers it doesn't really matter. Number of test cases, let's make it 20, and for each test case we need to tell it what kind of test cases they're supposed to be here, and I guess we forgot to put it in the repo. Let's just fix it here, and hopefully by the time you see this we'll have fixed it in the repo as well. And just to make something simple, we'll let the test case input just be I plus 1. I is ranging from 0 up to the number of tests, which is 20, so we're just adding the integers 1 up to 20 as our test cases. We'll set the likelihood to be 0.5, 50% chance of revealing a test case to students, and let's be generous and give them 5 seconds for each test case. In this case there's a single correct answer to the question, so the handler is just going to be basically a correct way to compute the answer. So for each test and test cases we compute the LCM of the range from 1 up to the given input. And this is something you don't need to change. This is just taking all the info we just did and sticking it into a list called assignment, which will be used later. Now let's look at another type of problem about Pythagorean triples where the answer might not be unique. So the goal here is to take an input integer n, and we want to find the Pythagorean triple such that a plus b plus c equals n. So triple, Pythagorean triple ABC, that means a squared plus b squared equals c squared, but also satisfying the condition that they sum up to the given integer n. The default answer here, let's just return always 0, 0, 0 for ABC. Let's create 20 test cases, and of course we need to do a bit of work here. We need to create some integers n that actually have Pythagorean triples summing up to them, and that's what this little code bit is doing here. It's just finding Pythagorean triples, and collecting integers that are their sum. Summa, by the way, is the Icelandic word for sum. So that's going to be our test cases, where we pick from available ends that satisfy this. Again, we'll give 50% chance of revealing a test case, and again, timeout 5 seconds. The difference here now is that there are possibly multiple correct answers. So we need to evaluate the answer that the student gives us. So first of all, the sum of A plus B plus C should equal the input end. And second, it should be a valid Pythagorean triple. So A squared plus B squared minus C squared should be 0. So you can do this kind of lambda evaluation when there might not be a single correct answer. And again, throw this into the assignment. In the next one, we are given a list of integers. The list is called L, and some integer k. And we want to find the first k digits of the sum of the elements of the list L. Again, give default answer. 0 is probably a good idea. Number of tests, let's do 20. And here I guess I just picked some random stuff, random integers from 10 to the power 25 to 10 to the power 30. And we can also vary the length of the lists here from 30 to 60. And we're going to take between 5 and 14 of the first digits. So the test case input is L and K. And I hate it when my students use lowercase l, so I shouldn't use it myself. It should be capital L, because lowercase l looks so much like 1. Again, 50% chance of revealing the test case. Timeout 5 seconds. Here there's a single correct answer. We can do it in a one-liner. Don't have to do it. You could do it outside and call it in here. But it's simple to do it like this and add it to the assignment. Problem 4, modulo square root. We want to find the square root of an integer modulo another integer. There are two input variables, default 0. Create some test cases. And here there are multiple answers again. So we evaluate what the student gives us with a lambda function. Is the student answer squared modulo the given modulus equal to what we want it to be? Add this to the assignment. Here's a problem that's mostly included to show you that you can assign questions that have just one test case. Here we're looking at something called K-poker and optimal stackings for it. And there's a unique answer and kind of a unique question you can ask about this. And they're supposed to return lists of optimal stackings for this K-poker game. There's going to be a single test case, which we won't reveal. So 0% chance of revealing the correct answer. And here we factor out how the correct answer is computed, and the handler just contains our correct implementation to compare against the student. So you can assign questions that have a single unique test case where it doesn't make sense to have multiple test cases. And I guess we've commented out here problem 6. So now we've filled in generate assignment.sage. We go back here. We're in the same folder. We need to run this with Sage. So Sage generate assignment.sage, enter, and if it didn't mess anything up, then a whole bunch of stuff gets created. There's an output thing in here which creates a bunch of files. First of all, you get this thing where students or yourself can fill in and play with the code. You get the playground where you can test your functions. It's taking a second to load for some reason. Let's let it sit for a bit and let me show you the test case files. So there's a real test case file, contains some inputs, and if you scroll down a bit, there's expected outputs. Some of them are going to be lambda functions. And remember, for the last problem, the kpoker one, we didn't give a test case, so there's going to be an empty dictionary for that one. If I can find it here. There's no test case revealed for the students and nothing to compare against as the correct answer. But if we go into the grading test cases, there we have all of the tests, not just the revealed ones. Again, there's no input for the kpoker one, but there is now a unique correct answer. Alright, let's see if it loaded the playground file, and here you can yourself, before you assign the homework, make sure that everything makes sense. You can implement this on yourself, for yourself, and check if all the test cases are passing like you want them to. And once you've made sure that everything is working properly, you can navigate out to the root folder, and now there was created an assignment folder here, contains your homework folder, and this is what you want to assign to your students. There's a solution file for them to write their solutions, just the revealed test cases, not the entire set of the grading test cases, and a playground for them to make sure things are working properly. Okay, the last step is to actually assign this to your students. How do we do that? Go to assignments, add an assignment. We called it homework 1. It looks for that and it finds two things. First of all, the version for you to play with and make sure everything works fine in the homework generation, and the one you want to assign to your students. So add that. Let's make it due sometime, let's say tomorrow by 2 p.m. Assign it to everyone. You can assign it to individual students. Let's assign it to all. Takes a second. And that should be it. Now in the final video we'll go through collecting from the students and grading by hand and also grading automatically.